So, hello everyone, today we are starting a new module, that is product recovery. So, in this module basically we will be focusing on downstream processing. So far we have discussed on upstream processing and heat and mass transfer concepts in bioprocessing, and last module was based on the instrumentation and control. So, there we first discuss that what are different sensors are needed in the bioreactor, what is the importance of the sensor. So, we discussed there can be inline sensor, online sensor or offline sensor. Further we discuss those parameters can be classified as physical parameters, chemical and biological parameters, and in the next lecture then we discuss how to monitor the key process parameters, their instrumentation and working principle. Followed by that we went to the process control. What is process control? So, basically we discuss that whenever there is some change or disturbance in the process, or you want to maintain a certain optimum condition, some corrective measures need to be taken, and those corrections are mostly done by the process control systems. So, in the process control systems there are various components. So, we say first is this measured variable or the measuring instrument, then it sends the signal to the controller, then controller compares this signal with the set point or the desired value, then it transmit the signal to advanced process control, and then it manipulates, does the corrective actions on the process. So, in this way the process control works. Then in the next lecture we discuss the process dynamics. So, here we discuss whenever there are certain changes or particularly bioprocess, we are dealing with the living system. So, everything is dynamic, it changes with the time, and when it changes with the time, then there should be a particularly dynamics, but that certain parameter, let us say DO is changing with the time, or the substrate concentration is changing with the time, biomass is changing with the time. So, whenever some disturbances are coming, then for reaching to the new equilibrium, how much time it will take, and if you know, then accordingly that corrective measures can be taken if required. Then in the last we discuss that how output signal for the controller is proportional to the error signal. The error basically is defined as difference between set point and measured value. So, measured value we are measuring the control variables. Then there we discussed different type of controllers, starting with proportional controller, then proportional integral controller, proportional differential, proportional derivative control, and the PID control. In addition to that, we also discussed the on off control, which is not very common in the large scale setting, but at a small scale they are applied. So, with this we summarize the last module, the process instrumentation and control. So, today we are going to discuss the first lecture, what is the importance of downstream processing. So, there we will be discussing first what is downstream processing, its overview, then what are different sequences or different steps in downstream processing, and why it is important, what is the economic consideration particularly involved in the effective and efficient downstream processing. Then we will summarize the importance and applications of downstream processing. So, you name any metabolites, any product, all need to be this purified, and when we go for the concentration and purification after the fermentation, those processes comes under the category of downstream processing. So, if you consider this is your bioreactors, So, all the operations after the bioreactor is called downstream processing. So, you can name any product starting with, let us say, antibiotics. It can have ethanol, it can have the acid, even it can have monoclonal antibodies. So, in all the cases you need to recover, you need to concentrate, and you need to purify the product. So, when we go for the purification, the first step is the fermentation broth. So, what it includes? It includes cells. It means first cells need to be separated. It includes extracellular product. It also includes intracellular product if your product is intracellular. It is also having unutilized substrate, and of course, certain impurities will be there. So, now you need to decide that how to remove the other components and concentrate on, it may be this your cell is a product, or extracellular product is a product, or intracellular product is your desired metabolite. So, accordingly you need to focus and concentrate. Now, separation choice depends, as I told, where is the product, location of product, whether it is intracellular or extracellular, what is the product size, charge and solubility, and what is the scale and what is the value of the product. Because when you are going to have n number of unit operation in downstream processing, you are going to add the cost. So, at the end, what is the value of the product? So, how much you can invest on downstream processing, and mostly it focuses on physical processes, but there are certain challenges. First is product in dilute solution. If it is dilute or your product titer is less, so you require the more number of recovery step, and ultimately it increases the cost. Second challenge is particularly these biological products like, let us say, antibodies or proteins. They are sensitive to the heat, they are sensitive to different solvent, they are sensitive to pH, they are sensitive to ionic strength. Third is there are chances that your fermentation broth is susceptible to contamination. So, once contamination is there, that can also be challenge to separate those contaminants, because until this bioreactor you are working in the aseptic or sterilized environment, but once you are taking away the product from here, it is difficult to maintain this sterilized condition all the time. So, what is the objective of downstream processing? The first is efficiently, reproducibly and safely recovering the target product to the required specification. As I told, you need to see, we require 90% purity, I require 99% purity for a given application. To ensure product purity, it is a biological activity and meet the regulatory standards, particularly for pharmaceutical and food products. Then from the commercial point of view, we need to maximize the product yield and minimize the cost. So, it should have high yield and economic feasibility. And last one is the reduce the loss of product mass, because in each downstream processing efficiency cannot be 100%. So, at each step there is some loss of the product, and as well as while downstream processing different unit operations are ongoing, the biological activity must be retained, it should not be compromised. And this depends, the level of purity depends on the specific use of a product. So, for a given application you need to decide whether the product is being used as a medicine, product is being used as a food product, or product is being used let us say for other purpose like animal feed or even let us say baker's yeast or so. So, depending on the application we need to decide the level of purity. So, now we can see what are the major process steps in downstream processing. So, we are not discussing upstream processing here. So, fermentation is already done. Now, we are starting here. The first thing is you need to separate the cell. So, this is called solid liquid separation. So, we have separated the supernatant, we have separated the cells. Now, one option may be your cells are product. So, now you have to concentrate here. Now, second option is you are having extracellular product, then your attention should be here, then it should go to the recovery and purification step. Now, third option is you are having intercellular product, again you are going to concentrate here, you will go for cell rupture, remove the debris and then you go recovery and purification step. So, in this way you can see your product can be cells itself, you can have intercellular product or you can have extracellular products. So, what are the key steps here? First is separation of insoluble products and other solids. Second is primary isolation or concentration of product, a removal of most of the water. It means you are going to concentrate. Third is then purification and removal of contaminating chemicals, purification step, and finally last step is final product isolation and product preparation or formulation. So, in this way first you separate the solids, then you go for concentration, then you go for purification, then finally we will go for formulation. So, this is a generalized downstream processing scheme. The same is elaborated in a better way. So, it says your product can be your cells or biomass, your product may be located inside the cell if it is intercellular product, or your product can be an extracellular product. Now, you are having the whole broth. What you are going to do? First, you are going to remove the cells. You remove the cells here. The first condition is product is the cell. So, you remove the cell, you got the product. In that case, you need to whatever liquid is there that you need to dispose or recycle. Second case is you are having intercellular product. So, what you have to do? You have to go for the cell removal. There are various ways to go for cell removal: filtration, microfiltration or centrifugation. So, by these method you remove the cell, then you have to go for the cell disruption. For that homogenization is a common method, and then soil homogenate you will be going for the again removal of solids like cell debris removal. The same method you can apply: filtration, microfiltration or centrifugation. Then you have removed the cell debris and whatever liquid is there, that you are going for the product enrichment. Then you are going for final isolation. The final isolation becomes, it may be crystallization, precipitation, ultrafiltration or drying. Then you go for product formulation. Third case, when it is extracellular product, you go for cell removal, then you have to dispose the cells. You are having cell free liquor, you are going for primary isolation. It may be solvent extraction, because here you need to concentrate first. It may be adsorption, it may be precipitation or ultrafiltration. Then you will go the same route, the product enrichment and then final isolation. So, here when you go for from one step to other step, you will see the product concentration or titer is keep on increasing. So, typically in the harvest the typical range is 1.1 to 5 gram per liter, but when you remove the cells it becomes 1 to 5 gram per liter. After primary isolation or extraction it becomes 10 times higher, 5 to 50 gram per liter. Then again it increases during the product enrichment 50 to 200, and in final isolation the concentration remains same. And interestingly, you just see the product quality also, the purity is keep on increasing and you can reach up to 90 to 100% purity. So, now depending on the application, whether you want to stop here at the product enrichment step or you want to stop here at the final isolation step. So, here I have listed just for information that titer of some of the, if it is cell product, you can typical Baker cyst concentration is 30 gram per liter. Extracellular product alcohol, one can go up to 100 gram per liter, while in case of enzymes and antibiotics to 20 gram per liter, typical value it may change, and in case of intracellular product, let us say recombinant DNA protein, it is about 10 gram per liter. Now, there are two key parameters which indicates the performance of downstream processing. The first one is the concentration factor, second is the separation factor. So, concentration factor is simply the concentration of product after treatment and concentration of product before treatment. So, typically the concentration of product after treatment will be higher. So, if its value is greater than 1, we say product is enriched. Second comes the separation factor. So, it comes the concentration of product divided by concentration of contaminant divided by concentration of product and concentration of contaminant after treatment and before treatment. And if its value is high, then it indicates it has higher selectivity, or your process works better for this given metabolite. So, these are the two important parameters to check the performance of downstream processing operations, concentration factor and separation factors. Now, this is economic consideration, because as I told initially, in the case of downstream processing it keeps on adding the cost. So, you can see the total contribution of downstream processing can be 40 to 90% of total production cost. And what it says, the product concentration as fermentation strongly affect the cost. So, the objective should be to increase the titer. That is why a lot of research is going on to how to improve the yield of the product, how to have the better strain, how to go for the better utilization of media, how to increase the concentration of your desired metabolite. Now, second comes product loss in each step. So, as I told, the efficiency of each downstream processing cannot be 100%. So, there are some losses in each step, and this cumulative loss can be high. So, let us say if you are having two steps and both are having the separation efficiency of 90%, 90% for step 1, then 90% for step 2. The overall efficiency has become now 0.9 to 0.9, it means it has become only 81%. So, you just see there is cumulative loss during this more number of steps in downstream processing. And this is again true, if there is a low initial concentration, means you need to have more recovery step, and then it higher loss, and accordingly there will be more cost. So, what are the way to improve? First, enhance the product synthesis during the fermentation, develop better downstream processing to minimize the loss. You can have this downstream unit operations which can give the better separation efficiency, it can be 99%, 98%. So, there are numerous unit operations exist. So, focus on the engineering principle of commonly applied recovery operations, and if needed some advancements or augmentations need to be done. So, for several products of bioprocessing, the higher the starting concentration is higher, the cheaper is the final material. It means accordingly the cost of downstream processing decreases. So, here you can just see if 80% retain per steps, and if there are total 6 steps in downstream processing, then what will be the total efficiency? It will be 0.8 into 6 times to the power 6. So, you are having ending up with only 26% product recovery, that is too low. So, it says that number of steps should be minimized. At the same time, this efficiency should also upgraded close to 90 to 99% or so. So, here you can just see the selling price and the concentration in starting material kg per meter cube. So, when this concentration is very low, you just see the selling price is too high for urokinase. Similarly, when concentration is high in the fermentation broth, then the selling price is low, while in the case, let us say in case of ethanol, it keep on decreasing for citric acid, then penicillin, then these are the insulin, then you are going to urokinase. So, you just see there is a linear decrease, or you can say there is a increase in the selling price with decrease in the concentration in the starting material. So, each picture includes the products of different categories starting from amino acids, antibiotics, enzymes, therapeutic enzymes, monoclonal antibodies. So, let us typically in the case of antibiotics, the fermentation cost is 60% and recovery cost is 40%. But in the case of newer antibiotic, this ratio is reverse. It means there is a 60% cost for the recovery, and for the product of biotechnology such as this recombinant proteins and monoclonal antibodies, downstream processing dominates. It contributes to 80 to 90% cost of total cost. So, now we can quickly summarize what are the general downstream processing schemes. The first step is cell removal. What are the options? Filtration, microfiltration or centrifugation. Now, there can be 2 steps. First is in the case of intracellular product, then we have to go for cell disruption and further recovery and purification. Second step is cell disruption and debris removal in the case of intracellular product needed. If product is intracellular, you need to go for homogenization followed by filtration or centrifugation to remove the debris. Then primary isolation, the methods are solvent extraction, adsorption, precipitation and ultrafiltration. So, it removes the component with very different property. The whole idea is to raise the concentration of the product. Then product enrichment, you remove the other chemical impurity. The method with higher selectivity like chromatography is used. Then final isolation and polishing, it depends on the product whether it is solid product or liquid product, and few methods for this step is ultrafiltration, crystallization and drying. So, now what are the importance of downstream processing? It ensures the high product purity, that is critical for pharmaceutical safety and contaminant removal, but it has certain economic consideration, particularly it may account for 50 to 80% of product cost, and when this efficiency upstream enhances the profit margins. Next is the regulatory compliance for a given product. It should comply with different regulatory standards, let us say FDA or so. Strict documentation and validations are there. Then scalability and sustainability. So, it supports scaling from lab to industrial production while managing the waste and recycling the solvent sustainably. So, the process should be sustainable. So, it says most of the solvents are most of the chemicals used in the downstream processing, they should be recycled and reused in order to maintain the zero liquid discharge policy or to have the zero waste. So, you name any, as I told initially. So, every sectors they go for, after upstream they go for downstream processing. It may be the pharmaceuticals, various drugs, vaccines, therapeutic proteins. It may be enzymes, isolation of enzymes for industrial and medical applications. The food industry, it can be bioactive compounds, flavors or additives, and various molecule even for the research and diagnosis purpose. So, in addition to that, if you name any solvent, even starting with ethanol, acetic acid, and those solvents are also produced and they have to undergo through different downstream processing steps. So, we can summarize now this what are the critical downstream processing step. The first is cell disruption, separation, purification, polishing to ensure product purity and quality. The economic consideration, this downstream processing greatly affect the profitability, because more number of steps means more downstream processing cost. Future innovations are needed for process integration and eco-friendly methods to enhance efficiency and sustainability. And last is the importance of stakeholders like researchers, engineers, educators and professionals. They must invest in downstream strategies to meet the growing biotech demands. So, with this I will stop here. So, in the next lecture we will be discussing different steps which are involved in the downstream processing. So, each important unit operations we will be discussing in the next lectures. Thank you so much.